Alright, welcome Ichak solution. This is matrix determinant of a 3x3 matrix here. Right, so if you haven't watched lesson 1 on the introduction and lesson 2 on matrix addition and subtraction, I do kindly ask you to go and look for the lesson. Right, so let's go here. Alright, so determinant of a matrix is denoted by vertical bars of A, date of what? Of A here. Right, so if A is a 3x3 matrix here, so we can use the method of expansion of the first row to find what? The determinant. So you can see your first row here is A, B, C. That's your first row here. Right, so we need to expand this first row. So determinant is equals to, alright, so we are interested in our first row, so there is A. Then on this one we put minus B, and this one we put plus C. So let's just see the process, how it goes about here. Alright, so expansion of A here, we are going to have A first, then we close the row of A and the column of A here. So we're going to be left with E, F, H, I here. Then minus B, then we close the row of B and the column of B here. Then we are left with D, F, G, I here. Then we go plus C here. Then we also close the row of C here and the column of C here. Then we are left with D, E, G, H here. Right. Then the next thing now we can find the determinant of this 2 by 2 matrix here, 2 by 2 matrix here, 2 by 2 matrix, and multiply with the corresponding values here, A minus B and plus C here. Right, so if the determinant is equal to 0, so what it actually means, it means the matrix is a singular matrix. Then the matrix does not have an inverse here. So sometimes the question might ask you, show that the matrix is a singular matrix. So we just need to find the determinant and prove that determinant is equal to 0. Or the question might say, show that it does not have an inverse. So you can also find the determinant, and if the determinant goes to 0, it means the matrix does not have an inverse. Right, so let's go to the question here. Alright, find the determinant of this one. So we are going to have the same method of expansion of the first row to find the determinant here. So it's very simple. So this is our first row. There is 3 minus 2 and 2 here. So we close the row of 3 and column of 3 here. So we are left with minus 1, 1, minus 1, 0 here. This is minus 1, 1, minus 1, 0. Then you say minus, then our B is minus 2 here. So it's minus 2 here. Then we close the row of minus 2 and column. Then we are left with 2, 1, 3, 0, 2, 1, 3, 0 here. Then we go to C is plus 3. Then we close the column and the row here. Then we are left with 2, minus 1, 3 minus 1 here. Alright, so the next thing now is to find the determinant of this part and determinant of this part and determinant of this part. Then we multiply with the corresponding element here. So this will give us 3 times 1 plus 2 times minus 3 plus 2 times 1 here. So this is minus 1 here. So this is our determinant here. Alright, so let's go to our next example here. Show that A is equal to this one, does not have an inverse. Alright, so to show that this matrix does not have an inverse, we just need to find the determinant and see that does the determinant equals to 0 here. Right, so we are going to do the same thing here. So this is our first row. There is 1, 2, 3 here. So we expand that row here. So it's going to be, we close the row of 1 and the column of 1. We are left with 4, 6, 2, 3 here. 4, 6, 2, 3. Then minus B. So our B is 2 here, so we close the row of 2 and column of 2 here. So we are left with 2, 6, 1, 3. Then we go on 3 again here, so 3 here plus 3. Then we have 2, 4, 1, 2 here. Alright, so this is the part. Then we find our determinants here. So the determinant here is 0 times 1 here, then minus 2. Determinant here is also 0 plus determinant here is also 0 here. So this will give us determinant of 0 for the final answer here. So which means this matrix does not have an inverse because the determinant is equal to 0 here. Alright, so next example here, find the value of x if M is a singular matrix here. So we need to find the value of x here. So a singular matrix determinant is also equals to 0. Alright, so let's go here. It's very simple. Alright, so we are also going to do the same thing here. So we are not going to demonstrating here, but since now I know we are now well vested with the closing of row and closing of column for the first row by expansion here, right? So for x minus 1 here, we'll be left with x plus 1, x minus 1, and 1 here. Then we go for minus, this is our b, so it's minus 2x, so we'll be left with x, then x minus 1, 1 here. Then plus, we go for c here, it's x plus 1, then we'll be left with x plus 1 here. Then we are going to finding determinants here, then we'll be multiply here, then minus 2x, we find determinant and we multiply with minus 2x, then x plus 1 here, also find determinant here and multiply. Alright, so this will give us this result here, and we equate to 0. Then if you simplify, we are going to be left with this expression 2x plus 2 minus 2x minus x minus 1 is equals to 0. So x is equals to 1 here. Alright, so this is the value of x for which this matrix is a singular. Alright, so you can test this value by putting 1 here, 1 in place of x. And you can also see that if you find the determinant, you are going to see that determinant is equals to 0 here. Alright, so now let's concept here. Alright, so to find the determinant of a 3 by 3 matrix, you can also use what we call the Sarah's rule. So Sarah's rule is used to find determinant of a 3 by 3 matrix, right? So if A is equals to this 3 by 3 matrix here, so you can use the Sarah's rule here. So let's just demonstrate the Sarah's rule here. Right, so the first thing is to take the matrix here as it is. That's the first thing that you do. Then you are going to add the first top 2 rows that on top, that is above the matrix here. You add them below the matrix here. So we are going to take the first row. So our first row is A, B, C, and the second row is D, E, F. So we take these first top 2 rows and add them below here. So I've added them here, so they are now below my matrix. So now I'm going to take the products of the diagonals from the top left corner here. So this is the first diagonal here, this one, the product here, then another product of this diagonal, and another product of this diagonal. So if I find the product of this diagonal and the product of this diagonal and the product of this diagonal, so I'm going to have the sum of those products. So this is A times E times I here. So this is A times E times I plus D times H times C plus D times H times C plus GBF. So this will give me a certain value A. Then I also find from the bottom here. So this is from the bottom. So this is A, B, I. Then this is A, the product of A, H, and F, and the product of G, E, C here. Then this will give me GEC plus AHF plus ABI. Alright, so this will give me a certain value B. Alright, so the determinant now is equals to the value of A, which is A minus what? Minus B. So this is how we find what? The determinant using Sarah's rule here. Alright, so let's go here. Find determinant of this matrix here. So we want to use the Sarah's rule. So the first thing we say, you copy your matrix as it is. Right, so this is our matrix. Then you add the first 2 rows here. So this is the first row and the second row here. You add it below the matrix. So now we are finding the diagonals from the top left corner here, going down here. So this is the first one. Alright, then this is the other one here, and this is the other one here. Alright, so you can see the first one here, 3 times minus 1, times 0 will give me 0. Then 2 times minus 1 times 2 will give me plus minus 4 here. Then 3 times minus 2 times 1 here will give minus 6. So the sum here will give us minus 10 here. Alright, then we go to the other side here. This is the diagonal here. From the bottom here, then another diagonal. Alright, so now you can see 2 times minus 2 times 0 is 0 here. Then 3 times minus 1 times 1 is minus 3. Then 3 times minus 1 times 2 is minus 6 here. So this sum here is going to be equals to minus 9 here. So now the determinant is given by this value where we add the product of the leading diagonals from the top left corner minus the diagonals from the bottom left corner here. So it's minus 10 minus 9 here. So that's our determinant. So determinant of A is equals to minus 10 minus 9, which is equals to minus 1 here. Right, so thank you for watching the video. See you in the next lesson.